Alright, these are solutions to the recent task you sat on comparing data distributions. So what we looked at in this task here was two classes at Mazenod College, or two maths teachers at Mazenod, and what one class did was use the Jack textbook, this one here, and another class used the Cambridge textbook. So let's analyse the data. Alright, so the first thing you had to do was draw an appropriate histogram for the results of the Jacaranda textbook. So the best way to do these problems is note that the data is going to have to get grouped. So you think about the grouping. These are marks, so maybe groups of 10 starting at 0 and see what happens. So let's get the calculator to draw the graph for us, or the histogram first. So we're going to go Control and Doc, and that'll allow us to do data and statistics. We'll add the Jack variable. We'll go and change the plot properties or plot type to a histogram. And now we're going to play with the plot properties, because what the calculator does is it has a guess as to what, how wide you want the columns to be. And it tends to never really get it right. So we're going to go Menu, Plot Properties, Histogram Properties, which is 2. Changing the bin settings, we're going to go Equal Bin Width. Okay, now this will allow us to manually set the width we want, which is, we want it to go in an interval of 10, starting at 0. Right, and you'll note then what it does is it automatically groups the data and will tell us how many values fall between the given intervals. So between 10 and 20, I know that there's one data point. So let's start to put this together. So what we're going to do is label our axes first of all. So we're doing the Jacaranda, so we're going to call this the Jacaranda scores. And over here we've got the frequency. So we've got 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And the frequencies, let's find out our max frequency. It's this one here, 5 points. So we can go 1, 2, 3, 4, and 5. Okay. Alright, so between 10 and 20 was 1. So I'd use a ruler if I was to do this on a piece of paper. But because I'm working with a stylus here, it's really hard to use a ruler for this stuff. So I'm freehanding it. Alright, followed by 5. Followed by 2 lots of 2, a 3 followed by 2, a 3, a 4 and a 3. Alright, and there's our histogram. Alright, now we do the same thing for the Cambridge textbook. So let's flick the variable over to Cambridge and change the grouping settings again. So we go Plot Properties, Histogram Properties, Bin Settings, Equal Bin Width, and let's do the same thing. So we have a width of 10 starting at 0. Alright, what we'll do again is label our axes. So we've got the Cambridge data here. So we'll go Cambridge scores and frequency, and 0, 10, 20, 30, 40. And what are we going up to? So our max score here is 9. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so we've got a 1, 2, and a 2. And the first grouping is between 20 and 30. So between 20 and 30 is 1. Then, oops. Then it was a 2, followed by another 2, followed by a 7, then a 9. So there's the 7. There's the 9. So again, stress the importance. This should be ruled by you guys, but I just can't do that with this thing. 5, followed by a 2. Alright, so there's our 2 histograms. So now what you needed to do is state the median and modal class for Jacaranda and Cambridge textbook. So let's set up a bit of a table. We'll go Jack and Cambridge, and we want median class and modal class. Alright, let's grab the modal class for the Cambridge data straight away while we can see the histogram. So we can clearly see that this class came up the most often. That's 9 of 60 to less than 70. So let's write that in as 60 to less than 70. And we'll just go back and check the Jack. The Jack data had a modal class. This one happened 5 times, so between 20 and 30. So 20 to less than 30. Alright, the median. Well, and we're after the median class this time. So let's check what the actual medians were. So first of all, I'm going to do menu 411, that's the one variable statistics, to try and find out the median of the Jacaranda data. Alright, so the median is down here somewhere. Here it is, median 59. So let's go to the Jacaranda data. So the median is 59, which happens somewhere in this class here. So we say 50 to less than 60. And let's do the same thing for the Cambridge data. So we're going to go menu 411 on the Cambridge data, and let's go down and check it out. So the median is 63.5, which means it must have happened between 60 and less than 70. Alright, now they want the mean and the standard deviation of the Jack and Cambridge data, so let's draw up a similar table, Jack and Cambridge, and we want the mean, which is X bar, and the standard deviation SX. Alright, now we just did the one variable statistics on Cambridge, so let's pull out these key stats from this data here. So for the Cambridge data, the mean to 2 decimal places, 61.32, and the standard deviation to 2 decimal places is 13.55. Okay, let's get the mean and standard deviation of the Jack data. So we're going to go menu 411 again, and we're going to pull up the Jack data, and the mean was 57.36. The SD was 26.46. Alright, so there's our mean and standard deviation. Alright, so what does the standard deviation of both sets of data suggest about the spread of Jack versus Cambridge? Okay, well, the fact that Jack has got a much higher standard deviation suggests that it's got a larger spread. Okay, so you needed to allude to something like that. So Jacaranda has a larger standard (26.46) compared to Cambridge. This indicates more variability or larger bred in the jacaranda data. Alright, so anything that sort of said something similar to that was fine. Okay, so now we want the 5-number summary for each textbook, so let's just get it. Now the last one I did, this was the jacaranda data, so I'm just going to go down and write the 5-number summary. So it's 13, 31.5, oops, 59, 82 and 98. So I'm going to go and do menu 411 again, okay, and what we want to do it on is the Cambridge data now. So we've got a min of 29, 54, 63.5, oops, what's going on there, 63.5, 70 and 82. So it says here the final score in the Cambridge data is 29, and we want to show why this is an outlier. So what we're going to do is the lower fence test, and that is Q1 take away 1.5 times the interquartile range. So we're doing it on this data here, the Cambridge data. Okay, so the Q1 was 54, and from that we're subtracting the interquartile range. Now that is going to be 16, so 1.5 times 16, which is 54 take away, what's that, 824. So your interquartile range, multiplied by that, yes, is 30. Okay, so that's our lower fence. Alright, so clearly then this score is an outlier, so we say something like 29 is less than 30, therefore it's an outlier. Alright, so we're going to do some parallel box plots here using the 5-number summary. So let's go and do, doesn't really matter where you do it, but Jack here and Cambridge here. Alright, so let's put the Cambridge data in first. Now 29 is an outlier. Just need to scroll down just a little bit more. Okay, so 29 is an outlier. So here's 30 here. We're just going to go a little bit less than there and star that. Okay, now you need a new min. Okay, and the new min is the next lowest value after 29. So let's just go back to the data, or you could get the calculator to do the box plot. In fact, why don't we do that? So let's go back to here, and I'm going to go and do control and doc and do a new data and statistics, and we'll go the Cambridge data, and I'm going to change the plot type to a box plot. Alright, so I've got 29, and the new min then will be 37. Okay, so again approximately there. Okay, and I'll scroll back up again to get the rest of my 5-number summary. So there's the new min at 37. We're over here. Okay, the Q1 is at 54, so there's 50 there. There's 55, so somewhere there would be appropriate. Then 63.5, so there is 65, so it's a little bit less than there. Then 70, that one's an easy one to measure up, so bang on that line there. Then 82, that's 85 there, so 82 would be somewhere there. Alright, roll a line across the top and bottom and form the whisker. Okay, so it's again important that you did rule this up. Okay, now let's do the 5-number summary for jacaranda. Now they haven't told us anything about outliers, so it's probably best that we again get the calculator to do this. Alright, so no outlier, so that's all good. We can just put this data straight in. Okay, so there's 10, 15, so there would be 13 around there. 31.5 is just a little bit more than 30. Then 59 is almost 60, so almost on that line there. 82, there's 85, so 82 is a little bit less than halfway there, and then 98, so around about there. Alright, so again you'd do this with a ruler. Okay, so using the box plots, compare the results for each textbook, making reference to shape, center, and spread, and we need to use stats. Okay, so first of all, let's look at the shape. Okay, now they're both probably approximately symmetrical. This maybe has a slight negative skew, so if you either used slight negative skew or approximately symmetrical for both, I would have given you the mark for this. So we're going to say that both the Cambridge and Jacaranda data is approximately symmetrical. Okay, so there's 1 mark allocated for that. Alright, now we need to look at the center, okay, and what we can see here is the Cambridge data has a higher center than the Jacaranda, okay, so we say something like the Cambridge data has a larger median, which was 63.5, I think from memory, compared to the Jacaranda data, which was 59. And finally, we need to compare spread. Okay, so I personally would prefer you to use the interquartile range to do this, because the range is actually affected by this outlier, but we didn't penalise you if you did. Keep the colour. So we'll say something like, so what we can see here is the Jacaranda data is going to have a larger spread than the Cambridge. So I'll say the Jacaranda data has a larger spread according to the IQR, and for the Jacaranda data the IQR is 82 take 31.5. Ooh, this is testing me out a bit. Oh. And that is 82 take away 31.5. I should be better at my decimals than this, but so that data there is 50.5. Let's spill over to the next page. Compared to the Cambridge data, which I think was from memory, let's just check it out, I did it up here, it was 16. Okay, and so the center comparison would have given you 1 mark, half a mark for larger or smaller, and another half mark for quotation of statistics, and the same down here with the spread. Okay, and just to the final questions, which ones would you use? A lot of students said that they would use the Jacaranda because it produces these higher scores, okay? But you got to remember that it also produces these lower scores as well. So you basically look at the median, okay, and that's the first thing you would use. So I would say the Cambridge straight away, due to the larger median. Okay, and because it has a larger median, I think 63.5, it basically means that on average students perform better when using that Cambridge textbook. But the other reason I'd use it is there's much less variability in the Cambridge results as opposed to the Jacaranda. So these were splayed all over the place, the Jacaranda data results, whereas the Cambridge data was a lot more predictable. That's what we like. We like less variation. So I would say for the first mark, due to larger median and less variation, or smaller spread. So that would have got you the second mark. Okay, what other things would you need to take into account before drawing final conclusion about which was the better textbook? This here was a pretty open question, and you know, there are a number of factors. Okay, you could look at something like teacher absence. Maybe one of the classes had a teacher that wasn't there for a portion of time. Okay, you could look at student ability. There was a class that just found maths a little bit more challenging than another class. Okay, you could look at classes missed. One of the classes lost a double due to athletics. Okay, so there's heaps of different things that really do affect the result rather than just the results. So again, looking at and using statistics, it's really important you understand that you go on more than just, oh look, higher median, therefore use it. You've got to look at a number of factors before you make a final decision on something.